So my name is Bolu Ajiboye. I am an assistant professor of biomedical engineering at Case Western Reserve University in Cleveland, Ohio. I have a PhD from Northwestern University in biomedical engineering, and I've been a faculty member at Case Western for about 6 years. I also work for the Lewis Stokes Cleveland VA Medical Center, and most of my work is related to brain-computer interfaces, BCI, applied to persons with spinal cord injury to restore movement after chronic paralysis. The colleagues that I work with for the past 30 years have been developing a technology called functional electrical stimulation. And essentially it is a technology which uses electrical stimulation to reanimate paralyzed muscles, so persons with paralysis can regain motor function, can regain movement. What we've done recently as part of the BrainGate clinical trial, which is headed by Dr. Leigh Hochberg at Massachusetts General Hospital, is we've been able to combine a brain-computer interface with this functional electrical stimulation technology. Now what the brain-computer interface does is it records brain activity that is related to reaching and grasping. We then take this brain activity and we decode it or decipher it. We try to predict what movement the person with paralysis wants to make. And once we're able to use our BCI to extract the intended movement command, we then send that movement command to the FES system. So essentially what we are doing is we are going around or circumventing the spinal injury. Because typically with movement, the brain sends a movement command which goes through the spinal cord, but with the spinal cord injury, that movement command can't get to the peripheral muscles and nerves. So with the BCI and FES, we have now gone around the spinal cord such that a person with paralysis can now think about moving, and then the arm and hand will move in the same way that they're thinking about. So in the submission, we showed basically a proof of concept that we could restore brain-controlled motor function, brain-controlled movement to a single person with chronic tetraplegia who had paralysis of the arms and hands. And so this is the first person in the world who's been able to use the BCI and the implanted FES to restore reaching and grasping. And as a result of our work, this person who was paralyzed 10 years before joining our study, he was now able to perform activities that we take for granted, such as drinking a cup of coffee, or feeding himself from a bowl of mashed potatoes, or even reaching and scratching his own face. Things that we take for granted he was not able to do because we were able to combine the BCI with the FES technologies. So we did submit our project to the BCI Award, and we were fortunate enough to win first place. And we were very grateful and very thankful that the committee saw our award fit to win first place. The party was great. There was music, there was food. We produced a video that was played there, and everybody got to see the work that we did. Everybody got to see our patient, our participant using the system. And it was a great time. We were very thankful to GTech, who sponsored the award. And again, we were very thankful to be a part of it. I think the BCI Award is important in our field. It highlights every year some of the top research and top work that's going on in our field, and it's important to highlight that for the general public and also even for researchers within our field. We are obviously very ecstatic to have won it, and it is a very important thing for our group. We basically believe that really it's our participants who have made this possible, the people who are benefiting from our work, and so really this award we accept it on behalf of them.